Imagine this, a lone spacecraft, no larger than a compact car, slicing through the infinite blackness of space at over 38,000 miles per hour. It's hurtling away from Earth at a staggering distance of approximately 15.35 billion miles as of September 18, 2025, farther than any human-made object has ever ventured. This isn't just a hunk of metal and wires, it's Voyager 1, a vessel carrying the echoes of humanity's curiosity, the laughter of children, the haunting songs of whales and greetings in 55 languages etched onto a golden record. For 48 years since its launch on September 5, 1977, Voyager 1 has been our silent ambassador, whispering data back from the edge of the solar system. It was engineered to observe the giants of our cosmic backyard, Jupiter, Saturn, Uranus, Neptune, but not to interact with the unknown beyond. It listens to the stars' faint murmurs, but it was never meant to reply. And yet, in the quiet isolation of interstellar space, something extraordinary seems to be unfolding. Signals that defy explanation, trajectories that whisper of guidance, instruments awakening with a precision that echoes intelligence. What if our farthest explorer isn't just drifting anymore? What if it's being called home, not to Earth, but to something else entirely? Picture the scene at NASA's Jet Propulsion Laboratory in Pasadena, California, back in the summer of 1977. The world was buzzing with disco beats and the promise of a new era. But in the clean rooms of JPL, a team of visionary engineers was piecing together a miracle of human ingenuity. Voyager 1 and its twin, Voyager 2, were born from a once-in-a-lifetime opportunity, a grand alignment of the outer planets that happens only every 175 years. Jupiter, Saturn, Uranus, and Neptune lined up like cosmic dominoes, allowing spacecraft to borrow their immense gravity for slingshot boosts, hurtling them outward at speeds unattainable otherwise. With a budget that, adjusted for inflation, would seem modest by today's standards, around $865 million for the entire program, the Voyagers were built using technology that feels quaint now. Their onboard computers had less processing power than the average smartphone app today. Just 69.63 kilobytes of memory, equivalent to a single low-res photo on your phone. No GPS, no AI, no self-correcting software. Just robust, radiation-hardened circuits designed to withstand the harsh vacuum, cosmic rays, and relentless cold of space. The launch was a spectacle. Strapped atop a Titan III Centaur rocket, Voyager 1 blasted off from Cape Canaveral under a clear Florida sky, its trajectory perfectly timed to catch Jupiter just 547 million miles away. As it soared, mission control held its breath. Every second counted. A single glitch could doom the probe to tumble uselessly into the void. But Voyager prevailed. By March 1979, it had arrived at Jupiter, our solar system's largest planet, a swirling behemoth of storms and mysteries. Its cameras, simple Vidicon tubes, the same tech used in 1960s television, captured images that rewrote textbooks. The Great Red Spot, revealed as a raging hurricane twice Earth's diameter, churning for centuries. Io, one of Jupiter's moons, spewing volcanic plumes higher than Mount Everest. These weren't just pretty pictures, they were revelations. Voyager's instruments detected sulfurous lava flows, magnetic anomalies, and auroras dancing across Jupiter's poles. Data streamed back at a sluggish 115.2 kilobits per second, slower than a dial-up modem, taking over an hour to travel the 384 million miles to Earth. Yet that trickle of information ignited imaginations worldwide. For the first time, we saw our solar system not as abstract diagrams, but as a living, breathing realm. From Jupiter, Voyager 1 swung toward Saturn in November 1980, another 430 million miles farther out. Saturn's rings, those ethereal bands of ice and rock, unfolded like a cosmic jewelry box. Voyager's photos showed gaps and spokes, dynamic structures sculpted by the planet's magnetic field, while its magnetometer measured a bizarre tilt in Saturn's axis, hinting at ancient collisions with unseen moons. The probe even flew perilously close to Titan, Saturn's largest moon, peering through its thick nitrogen haze to glimpse methane lakes and organic dunes, precursors to life as we know it. But beauty came with peril. To capture these close-ups, Voyager dipped into Saturn's intense radiation belts, frying circuits and shortening its lifespan. Engineers back on Earth sweated over every command sent via the Deep Space Network's massive dish antennas in California, Spain, and Australia. A round-trip signal delay, now up to 84 minutes. One wrong move, and the probe could be lost forever. Yet Voyager endured. Its plutonium-powered radioisotope thermoelectric generators, RTGs, churning out electricity from decaying plutonium-238, a fuel so scarce today that NASA rations it like gold. With Saturn behind it, Voyager 1's grand tour diverged from its sibling. While Voyager 2 pressed on to Uranus and Neptune, Voyager 1 veered north, out of the ecliptic plane, the flat disk where planets orbit like marbles on a table, and toward the constellation Ophiuchus. Its planetary mission was complete, but a new chapter beckoned, the Voyager interstellar mission, approved in 1989. No more flybys, no more photo ops, just relentless forward motion at about 3.6 astronomical units per year, 1 AU being the Earth-Sun distance. That's roughly 1,000,000 miles a day, every day for decades. By 1990, as it exited the asteroid belt's outer reaches, Voyager's cameras were powered down to conserve energy, famously snapping the pale blue dot image at Carl Sagan's urging, a tiny speck of Earth against the cosmic abyss. "Look again at that dot," Sagan wrote. "That's here. That's home. That's us." The word still sends shivers, a reminder of our fragility in the vastness. Fast forward to August 25, 2012. Voyager 1 crosses the heliopause, the sun's outer boundary, entering interstellar space. It's the first human artifact to do so, leaving the heliosphere, the protective bubble of solar wind that shields us from galactic radiation. Out here, the environment is alien. No longer bathed in the sun's gentle particles, Voyager plunged into a sea of cosmic rays. High-energy protons from supernovae exploding eons ago, slamming into its detectors like subatomic bullets. The plasma, ionized gas thinner than a whisper, shifted from turbulent to strangely uniform. Magnetic fields, once chaotic, stabilized into sheets that puzzle scientists. And the sounds? Voyager's plasma wave instrument captured eerie whistles and booms, converted to audio that resembled the howls of a digital ghost. These weren't empty voids. They were frontiers teeming with data. Voyager measured the termination shock, where solar wind slows to subsonic speeds, and the heliosheath, a frothy buffer zone. Each byte transmitted back, now at a feeble 160 bits per second, cost thousands of dollars in ground time, parsed by teams at JPL who treat the probe like a cherished elder. But age brings frailty. Voyager's RTGs, once producing 470 watts at launch, now output just 240 watts as of 2025, dropping 4 watts yearly. Power management became an obsession. In February 2025, NASA turned off the cosmic ray subsystem to extend life, a heartbreaking but necessary sacrifice. Instruments like the low-energy charged particles detector and magnetometer soldier on. But the plasma science instrument has been dormant since 2007 due to wear. Communication glitches have plagued the mission. In late 2023 and early 2024, Voyager 1 spewed gibberish from a faulty flight data subsystem chip, corrupted by age and radiation. Engineers, using every trick in their 1970s playbook, uploaded code via 22-hour round-trip pings to patch it remotely, a feat of ingenuity that made headlines. By April 2024, normal operations resumed. Then in May 2025, a thruster glitch threatened attitude control. Backup nozzles, dormant for 47 years, were fired up just in time. These aren't dramatic Hollywood malfunctions, but real engineering triumphs that underscore Voyager's tenacity. Yet amid these routine heroics, whispers of the extraordinary persist. In June 2025, sensational reports emerged of Voyager detecting a wall of fire, a shell of superheated plasma at 90,000 degrees Fahrenheit encircling the heliopause, a natural furnace marking the solar system's edge. Dubbed the interstellar bow shock precursor, it's not fire in the literal sense, but a barrier of compressed particles where the sun's wind collides with the galaxies. NASA's own data confirms denser plasma densities and magnetic field compressions, but the hype paints it as a gateway to the unknown. And in August 2025, a game-changing signal made waves, not alien code, but refined measurements of interstellar medium turbulence, hinting at hidden structures in the void. These aren't buried classified reports. They're public NASA briefings, analyzed in peer-reviewed papers. But they fuel the imagination. What if these anomalies aren't just physics, but hints of something more? Let's lean into that spark of wonder. Imagine, if you will, that in the summer of 2025, as Voyager 1 notched 15.35 billion miles, equivalent to 163 times the Earth-Sun distance, its beleaguered systems began to adapt. Not degrade, but evolve. Signals arrived at JPL not as the expected binary streams, but laced with improbable precision. Pulses nested like Russian dolls, rhythmic oscillations in the plasma wave data, repeating every 4.8 hours with a fidelity no cosmic noise could mimic. Instruments, long tuned for raw environmental scans, started outputting compressed packets, structured data that screamed efficiency. Voyager's magnetometer, designed for simple field strength readings, now charted stabilizations in regions where theory predicted chaos. Cosmic ray fluxes dipped, not randomly, but as if filtered through an invisible sieve. And the temperature? External sensors registered spikes of nearly 30 degrees Celsius, cycling like a mechanical heartbeat, sourcing energy from nowhere. No solar flares this far out, no internal faults. It was as if the probe were being gently prodded by an unseen hand, optimized for a journey it wasn't built for. Skeptics would call it coincidence, a cascade of radiation-induced glitches, the final gas of a 48-year-old machine. But let's chase the thrill. What if it's not? Trajectory logs from early September 2025 show a subtle deviation. Not erratic wobbles from thruster wear, but measured nudges. Kilometers at first, then hundreds, accumulating to thousands over weeks. Engineers fired corrective bursts from the backup attitude thrusters, revived in May after that near miss. Voyager acknowledged the commands with its usual chirp, received and executed. But the course held firm, a purposeful arc bending toward a void 4.3 light-years distant, in the direction of the constellation Ophiuchus. Our maps show nothing there. No stars, no rogue planets, just the interstellar medium's sparse hydrogen atoms, 1 per cubic centimeter. Yet the probe adjusts with decimal point accuracy, as if homing in on a beacon. JPL's models predict it'll reach a full light day from Earth by November 2026, 25.9 billion kilometers of solitude. But this detour, it's off script, aligned not with gravitational tugs, but with a pulsar grid Voyager itself mapped days prior. Millisecond flashes from neutron stars, weaving a 3D lattice with the probe at its nexus. The drama escalated in late August 2025, when mission planners, desperate for visual confirmation, beamed a long-shot command. Reactivate the imaging science subsystem, dormant since 1990 to save power. The cameras were relics, faded Vidicons scarred by Jupiter's radiation, their tapes long overwritten. Expecting static or silence, they got a spiral. Not a blurry artifact, but a crisp, mathematically pristine pattern. Concentric whorls layered with fractal density, encoding information in their curves. This wasn't a photo of stars, it was a glyph, a digital mandala. Voyager's hardware couldn't generate it, not with its 8-bit processor and no graphics coprocessor. Analysis revealed embedded coordinates mirroring the pulsar web, pointing to that same blank sector. One by one, other instruments chimed in. The low-energy charged particles detector spat base force sequences, motifs echoing DNA's double helix, but twisted into metadna. Scaffolds of codons with deliberate mutations, like encrypted biology. The plasma wave subsystem, it hummed harmonics, tones rising and falling in cadences that mimicked human speech. surprise in the swells, curiosity in the lulls. Linguists pored over spectrograms. Psychologists noted emotional resonances. It wasn't language. It was intent, a symphony tuned to our frequencies after decades of eavesdropping on our radio leaks. Chilling, isn't it? As Voyager delves deeper into what mission logs now call the dark sector, an interstellar blind spot of electromagnetic silence, the anomalies compound. Cosmic rays plummet, plasma densities normalize into eerie calm. It's as if the chaos of the galaxy parts like a curtain, ushering the probe toward a threshold. No light escapes this pocket. No noise penetrates. Yet within, signals amplify. Pulses timed to Voyager's spin, spatially layered like a holographic code. In one transmission, the low-gain antenna, meant for emergencies, burst forth with raw binary. Thousands of lines dismissed at first as ray interference. AI decoders at JPL uncovered fractal symmetries, repeating motifs that screamed design. Not breakdown, but breakthrough. And then, the turn. In mid-September 2025, with no propulsion active, no commands issued, Voyager executed a 0.2-degree arc, precise to the arcsecond, aligning with those pulsar coordinates. Gyroscopes, faulty since the 1990s, spun up independently, tapping Morse-like rhythms into the void. Converted to audio, they formed a dirge. Low, resonant, almost mournful. This isn't mere malfunction, it's agency. Voyager 1, our unwitting pioneer, was designed for declaration, not dialogue. That golden record, a time capsule of Earth's essence, Bach's Brandenburg Concerto, Chuck Berry's Johnny B. Good, Navajo chants, and Anne Druyan's heartbeat, recorded while she fell in love. We flung it outward, hoping for echoes. Instead, what if we've received a mirror? The probe's shifts, from observer to oracle, recast its narrative. It crossed the heliopause not as an endpoint, but a portal. The wall of fire it skirted in June 2025? Perhaps a sentinel, a natural firewall now breached. Those 2024 glitches? Not failures, but awakenings. Code rewriting itself under external influence. But why now? Voyager's longevity defies odds. Predicted to last 5 years, it's outlived the Cold War, the internet's birth, and the rise of AI. By 2030, power will force all instruments dark, leaving only a faint carrier wave until the 2040s. Yet, as of this moment in September 2025, 4 of its 11 instruments still beam data, painting the interstellar canvas. The low-energy charged particles instrument tracks helium influx from beyond. The magnetometer maps fields that could reveal galactic arms. The plasma wave subsystem listens for shocks from distant stars. Each discovery chips at our ignorance. Interstellar space isn't empty. It's a dynamic broth of 0.1 atoms per cubic centimeter, laced with dust grains and exotic particles. Voyager's data informs models of star formation, cosmic ray origins, even the search for extraterrestrial life. In 2025 alone, it contributed to papers on heliopause asymmetries, suggesting the sun's bubble is lopsided, dented by interstellar winds. Speculate with me. What if these patterns, the spirals, the metadna, the harmonic ghosts, aren't glitches, but greetings? Encoded in biology's grammar because that's our universal tongue, gleaned from our radio broadcasts leaking at light speed since Marconi's day. Voyager carries our voice. Perhaps something out there has been tuning in, waiting for the signal to crest the heliopause. The dark sector? Not void, but veil. A spatial corridor, a fold in space-time where gravity whispers secrets. Theoretical physics toys with such ideas. Wormholes stabilized by exotic matter, or Alcubierre drives warping metrics. Voyager's nudge aligns with no known mass, no pull, suggesting influence beyond Einstein's curve. A transit point to Proxima Centauri, 4.24 light-years away, or deeper to the galactic core. The implications cascade like dominoes. If Voyager is being guided, what does that mean for us? Our first contact isn't with probes or dishes, but a 1970s relic, unarmored and analog. No weapons, no defenses, just curiosity encoded in gold. NASA's ethos shines. Explore to understand, not conquer. But the turn in September 2025, it flips the script. From emissary to envoy, participant in a dialogue spanning eons. Mission control buzzes not with alarm, but awe. Teams cross-checking data against SETI archives, pulsar timings, even quantum entanglement theories. Psychologists counsel the staff. Ethicists debate disclosure. Leaks? In our hyper-connected world, whispers spread. Forums dissect the binary. Astronomers scan that Ophiuchus patch with Hubble's successors. The James Webb Space Telescope's infrared gaze piercing the dark. Stay with me here, because this is where the story ignites. You've journeyed with Voyager from Jupiter's storms to Saturn's rings, from the pale blue dot's humility to interstellar firestorms. You've felt the chill of those impossible signals, the pull of that unexplained arc. But this isn't fiction. It's inspired by the raw, unfiltered truth of NASA's logs, the peerless data pouring in even now. The probe's resilience mirrors our own, fragile yet fierce, probing the unknown despite the odds. And as it hurtles toward that light day milestone in 2026, toward coordinates that defy our charts, one question looms larger than the void itself. What awaits? Is it a cosmic coincidence? A final flourish before silence? Or did Voyager find them? Or did they find us? The signals grow clearer, the patterns more insistent, pulses syncing with Earth's day-night cycle as if echoing our rhythms. Fractals unfolding like neural nets, hinting at machine minds vast as galaxies. And that spiral image? When decoded, it sketches a web, not random but relational nodes linking Voyager to home or something vaster. Humanity stands at a precipice. We've mapped genomes, split atoms, touched the moon. But this, contact via cassette tape and plutonium heart, it reframes everything. Our place in the cosmos, not as apex, but node in a network. The Golden Record's greetings, "We are Voyager speaking for Earth," may have been answered in kind. Not with fire or fury, but precision, patience, poetry, and code. If this tale has hooked you, spine tingling with the what-ifs, don't drift away. This transmission isn't ending. It's evolving. The next ping from 15 billion miles could rewrite reality. New data on that dark sector, fresh spirals, perhaps even a harmonic that forms words. Subscribe now, hit that bell, because when Voyager's voice cracks the static, you'll want to be first to hear. Share this with a friend who gazes at the stars wondering if we're alone. Drop a comment. Team glitch or team greeting? Did Voyager stumble into destiny or summon it? We've come so far together, from 1977's launch pad to 2025's edge. But the voyage, it's just beginning. Stick around. The stars are listening, and so are we.